Hello, this is Understanding Mathematics, and you are watching How to Make Less Mistakes When Solving Math Problems. 7 Practical Tips. When I was in school, many teachers warned about careless mistakes. But I didn't find the advice, just be more careful, to be very helpful. This video contains tips for finding and preventing mistakes. These tips are based on my own experience, both as a student and an instructor. 1. Make sure you actually read the question and understand it. It's difficult to get it right if you're answering a different question. After you find an answer, ask yourself, did I answer the question? If the question has multiple parts, make sure you have answered all of them. What helped me was copying the question by hand, or at least copying the most important information, because that would force me to actually read it. Maybe underlining or highlighting works for you. Even if all your homework is online, I strongly recommend writing things out by hand. 2. Be mindful of easy steps, those that a 10-year-old would know how to do. I noticed that many times I would do all kinds of complicated math correctly, but then make errors in the easy steps. Here are some examples. I would say something like 2 times 3 equals 5, so I would accidentally add the numbers instead of multiplying them. Or I would change an x to a y. Why do these mistakes happen? I think it's kind of a subconscious attitude. Your brain thinks, this part is easy, so I can relax. When solving a problem or tracing for errors, be mindful of the easy steps. This includes simple calculations and copying expressions. 3. Write down intermediate steps. I know, it's boring. I realized that many of my mistakes were caused by doing too much math in my head. You might save some time by skipping intermediate steps, but it's not worth it if you get the wrong answer. One common place where intermediate steps play a big role is solving equations. Let's do an example. Imagine you're solving 2x plus 6 equals 0. If you take the time to write down the intermediate step 2x equals negative 6, you are less likely to make a sign error. And these kind of errors I see all the time. Writing down intermediate steps makes it easier to find mistakes. You don't need to repeat the same 5 steps mentally, and likely repeat the same error when doing that. 4. Check your work without relying on answer keys. We'll do a couple of examples, and first of them is factoring polynomials. Let's say you want to factor a polynomial x squared plus 5x plus 6, so you want to find numbers that add to 5 and multiply to 6, so 2 and 3 are done. Okay, but the thing here is if we think about what's happening, going from left to right is factoring, which is significantly harder than going from right to left, expanding. So I would recommend expand the brackets to check, at least mentally, if you don't want to write it down. For calculus students, another example, so when calculating indefinite integrals, check your work by taking the derivative, because taking derivatives is way easier than finding integrals. 5. Estimate the answer, even very roughly. Let's do an example. Let's think about a $2,000 deposit with 3% interest, and let's say $100 is withdrawn at the end of each year. And the question is, what is the account balance after 10 years? Okay, so first year you get $60 in interest. That is 3% of $2,000. This is less than the amount withdrawn. So second year you will get less interest because there is less money in the account. Which means the account balance keeps going down, and we can conclude that answer should be less than $2,000. Let's continue with the example. The total amount withdrawn is 10 times $100, which is $1,000. So the answer is at least 2,000 minus 1,000 equals $1,000. So based on the estimates, the answer should be somewhere between $1,000 and $2,000. And keep in mind, this is a very rough estimate. But negative numbers or answers in the millions don't make sense. And believe it or not, I have seen both of these answers in a problem like this. If you're using a calculator, a rough estimate can help you reveal an input error, and this can be really useful as well. 6. Solve the problem in 2 different ways. You should get the same answer. If you can come up with 2 different methods to solve the problem, and the answers agree, then it is very likely that your answer is correct. However, if you get different answers, then at least one of your solutions contains an error. 7. Think instead of relying on memory. I think this is a big one, so I wanted to save it as last. Human memory is unreliable. I like to compare studying mathematics to building a brick wall. If the lower layers are shaky, the whole wall will collapse. Memorizing might work well for your exam next week, but it is rarely a good long-term solution. The main principle of this channel is the more you understand, the less you need to memorize. Mathematics is often taught using the approach, here's the formula, use it. Computers are able to plug in numbers into formulas. I believe that humans can do better. Let's look at what are some dangers of formulas. You might be using a formula which is meant for a different situation, or you might be just misremembering the formula. And that comes down to human memory is unreliable. For example, I have seen students use several incorrect versions of the quadratic formula. I think that completing the square is a much better method for solving quadratic equations, even though it may take some effort to learn. So how do you know if a formula is valid? Let's do an example. Can you simplify square root of a plus b to square root of a plus square root of b? This looks like a reasonable formula. It's similar to square root of ab equals a square root of a times square root of b. So surely the same is true for addition as well, right? Let's find out. If square root of a plus b is equal to square root of a plus square root of b, then this is true for all values of a and b. So let's try a equals 1 and b equals 0. We get square root of a plus b equals square root of 1 plus 0, which is square root of 1, which is 1. Okay. What about square root of a plus square root of b is square root of 1 plus square root of 0, and we get 1. Okay, so it seems it worked for these numbers. So does this mean the formula is valid? Well, let's try some other numbers. How about a equals 4 and b equals 9? Square root of a plus b is square root of 4 plus 9, which is square root of 13. And on the other hand, square root of a plus square root of b is square root of 4 plus square root of 9, which is 2 plus 3, and that's 5. And now the question is square root of 13 equal to 5? Well, square root of 13 is a number that if I take its square, I should get 13. But 5 squared equals 25, and that's not 13. So no. The formula is not valid because it didn't work for all numbers a and b. and I see this formula, so-called formula, used all the time. So when you are going to use some kind of formula, stop for a moment to think. Are you sure that the formula is valid? You can try in some numbers like was done in the square root example, especially if you're not quite sure if the formula is valid. But here's a warning. Finding numbers that work does not mean that the formula is valid. Let's see. In the square root example, we found that square root of 1 plus 0 equals square root of 1 plus square root of 0. So for these two numbers, the formula seemed to work. But for 4 and 9, it didn't work. So this means square root of a plus b cannot be simplified to square root of a plus square root of b. It didn't work for all numbers. Let's do a little real-life example. Let's say someone claims that all students have glasses. You cannot look at one student who wears glasses and conclude that everybody does. But if you find one student who does not wear glasses, then you know that the claim is false. So back to formulas. There are infinitely many numbers, so you cannot check all of them, of course. But trying in numbers can help you detect incorrect formulas, and that's why the method is very useful. Here are some final words. Mistakes are inevitable, both in life and mathematics. As Albert Einstein once said, anyone who has never made a mistake has never tried anything new. And I really resonate with this quote. However, it is foolish to keep making the same mistakes over and over. When you make a mistake, take it as an opportunity to learn. Don't just erase and try to forget the mistake. Instead, make a note to yourself. Maybe you can find your typical mistakes and then be able to avoid those. This is a strategy that I took when I was studying. I hope this video will help you avoid mistakes. Thanks for watching. If you have any wishes for future videos, let me know in the comments.